General solutions to differentials. Basically, when we ask you to find the general solution to a differential, basically we're asking you to find the original function. So calculate the original function.
Well, what's the difference between that and the other one?
And in fact, it is a function. It's what?
What's the difference between that and finding an integral?
That's, you're going to use an integral to find the original function. This is a derivative, right? How do you undo a derivative? With an integral.
So why don't they
Okay,
just
so
say find an integral?
the first step, though, is to separate the variables. There are instances where they're not separable. You have to put all of the y's over here and all of the x's over here. Yeah, separate the variables. That's the first step. So how am I going to put the y over here? Multiply, yeah. And how would I put the dx over here? Anybody? Multiply, yeah. Separate the variables so you get all the x's, all the y's. You okay with that? Now, we can integrate. Integrate, right? So we have an integral y dy. See how everything is nice and calculus pretty here. The y and the dy match up. So what's the integral of y? Well, the derivative of y is 1. Don't get it mixed up. Okay. Do I need to put a plus c? You only need a constant on one side. Okay, so we always reserve it for the right side for some reason. Because of those sides. If I put a c and a c over here, they would cancel each other out. But all we need is 1. Okay. So just a little tidbit there. And now solve for y. Solve for y. You need, your goal is y equals. So multiply by 2, square root. Okay. Do I need to put 2c? You don't have to, but it's proper notation. This is a constant, that's a constant. It's just multiplied by 2. Okay, so you can leave it as is, and then square root, right? There you go. That's our general solution. Positive or negative?
Oh, we just dropped it.
It was, but here, let's just not. So I don't Yeah, it doesn't matter. Tomorrow I'll show you how to calculate C. And if you put 2c in there, it gives you a c value, and you end up doubling it to write your equation. So it doesn't really matter. It gives you the same. Okay, so this is a very straightforward. Here's the original. This is the derivative. Okay, so the key there, though, is that the variables have to be separable. If I give you something like this, variables are not separable in that question. So we can't do this.
Wait, why? Because you can't use y.
It'd be dy minus y. It would be multiplied together, we can't integrate that.
Oh, okay.
It'd be dy dx minus y. You can't read the dx without the statement. So anything with an addition like this is not separable, we can't deal with it. So these don't even usually come up on the AP exam. All we're asking you about is separable. So let's look at this one here, number 2.
What happens if they do come up, what do you say? You just say no solution or?
They're not separable. Yeah. We'll look at some free responses, so you're ready for that kind of thing. Okay, if I separate the variables here, I can, number 1. What do I end up with on the left? Okay, so we're all y's and all x's, right?
Yeah.
Now I can.
Correct.
Any ideas on that one? Yeah, you saw.
Oh.
It's funny. U is squared. Okay. 1/3 du is x squared, right? Yes. So I'm gonna rewrite it just keep myself straight. Always good to write out all your work. It keeps things nice and organized, especially when you're 3 hours into an AP exam. What is the integral of sine? You guys are studying. And then u was x cubed, right?
No.
And then solve for y. So y equals. There you go. Good solution.
Oh, but you gotta do something.
Yeah, this is still possible because the constant can be bigger than this negative. Right. So you're thinking, oh my gosh, that's a negative square root. That's not possible. But it is because we don't know this constant. I mean, it could work still. Like if the value of this was 1, it would be -1/3 plus maybe a 3. Okay, so
Is it okay if we leave it 1/3 negative cosine?
yeah,
Or does it have to?
just make sure that you write it like this. So it's not minus. Yeah. I think it's- Yeah. Okay. I'll show you one more, and then we'll be done. Let's do that one. This that I'm going to show you is the most common kind of problem you'll see for differential equations. How do I move the y? I divide. So I end up with this.
Okay.
divide y over, it's 1 over y, right? When I integrate, the natural log of,
What if you did y to the negative 1? You said that?
no. Then it would be y to the 0. There's nothing for that. This is the definition of natural log.
Then you can't do that for
If it's y to the negative 1 or 1 over y, you have to use natural log.
That's good to know. Side to side.
How do I deal with that?
Oh, you have to go with E.
We have to use E. The big, and this will come up tomorrow, where I'll show you how to deal with the absolute value. Okay, I'll show you how to do that with specific solutions tomorrow. For now, that's an exponent. This is not how you're generally going to see one of these answers. Do you remember your exponent rules? How can I rewrite this? I'm running out of room here. And what would the C be? It would be B to the C. Remember when you have multiplied same base, you add the exponents? Then, oftentimes you'll see this in a multiple choice. They'll take it and they'll do this.
Or is it just?
E to this, no, it's times. E to the C is just a number, correct? It's just a constant, so they'll actually stick it up right here as a C. If you're working on a multiple choice, this is probably the format you'll see an answer. Yeah. When you're getting to this point, this is the process.
Oh, so then just ignore that and use it quickly.
You're not ignoring it. It's mathematic. This is mathematically sound. Okay. Tomorrow, I'll show you how to find that constant. Either one of these will give you the same number. Because the C value would be different here than this one. This, if I solve for C here, it would give me the same number as this. If the C value would be different because it's an exponent.
Oh, so the C itself.
They give you the same number. It's just a different format. So that's solving separable differential equations or general solutions. These will be probably in the calculator. Okay. Well, basically what you're solving for there is any one of these curves. The constant tells us where to place it. We just don't know where to put it, okay? So tomorrow I'll show you how to place it in a certain spot. Any questions? This is an algebra exercise, really. You can, if you can separate and integrate, the rest of it's algebra. And we'll get plenty of practice. Don't worry. Last year, last 2 years, this concept alone with slope fields is worth about 10% of your test. It was a free response, 9 points, and a multiple choice or 2. So it's 10 or 11 points for your exam last year. It's very good for us to get this down.
Wait, this is still considered a slope field problem?
Well, it's a differential, right? So that's how we relate them. They would combine them into the same free response. So you're given a differential, generate a slope field. What is the general solution to the differential? That can all be in one problem. Because it's all dealing with differentials, derivatives. Questions? This makes sense. You're in good shape. That makes me smile. We're just gonna have to deal with this as it is. Tonight's homework. from the book. This is all I'm gonna ask you to do. So tomorrow we'll score the slope fields for official, and then we'll look at these. I took the spiraling off, I'll give it to you over the weekend, so if you need to work on that slope field stuff, have at it. And they're all odds, so you have the answers. Check your work, okay?
That's it? Oh.